This is the second day on Chapter 6, Section 6, titled Systems of Linear Inequalities. And so let's take a look at our problems here. And so the first one says, Mark is a student and can work for at most 20 hours a week. So that's an important part right there, so let's underline that part. At most means less than or equal to 20 hours. He needs to earn at least, so that means greater than or equal to, $75 to cover his weekly expenses. His dog walking job pays $5 an hour, and his job washing cars is going to end up being $4 an hour. Write a system of linear inequalities to model the situation, graph the inequalities as well. So let's call, we have two unknowns here. Walking the dog, number of hours of walking the dog. So how about D equals dog walking, so number of hours dog walking. And then we're going to say maybe like C equals number of hours washing cars, car washing. And so we'll start with the first equation. It is he can work for at most 20 hours a week. And so we have D plus C, so he's going to be doing the two different jobs. So D plus C has to be less than or equal to 20, because at most means that amount or less. He can't work any more than that. And now he needs to earn $75 a week to cover his expenses. He has to have at least that amount. So we have to go with the value of the dog walking, $5 an hour, plus $4 an hour for doing the cars, times the number of hours, and times the number of hours here as well. It has to be greater than or equal to, and this is $75. So now we've got our two systems set up, and let's go ahead and graph it. So we'll call, how about D represents the hours washing the car down here. So we'll say this is the C-axis, so hours washing cars, and we'll say this is the D-axis, as this is hours walking dogs. And so now we need to be able to graph it, and let's start off with looking at and possibly going by fives here. So we go 5, 10, 15, 20, 25, 30, 35, 40, and we'll do the same thing here. How about 10, 20, 30, and 40? And let's go ahead and plot some of these. So this is a good one for intercepts. So the D-intercept is going to end up being 20, the C-intercept is 20, and the points in between are going to be right there. So this is a solid line, and we are going to end up shading below this line. Below because it has to be at most, so that means it can't be any more than that $20 line, or it can be that amount or anything less. And so the next one says 5D plus 4C is 75. So let's go ahead and use the intercept method again. So 5D is going to end up being greater than or equal to 75. So you do the division, and we see that 5 goes into 7. We have there one time with 2 left over, so it's going to be 15. So D is going to be greater than or equal to 15. So we go down to 15, and we put a dot there. So there's our 15. Let's change colors. Put 15 right there, and then we'll go with the 4C. 4C is greater than or equal to 75. So we divide by 4, and we see how C is greater than or equal to, and then 4 goes into the 7. Goes in there one time with 3 left over. It goes into 35 almost 9 times, but only 8. So that's going to end up being 32 with 3 left over. So it's going to be 18 3/4. And so we'll go over to 18. So it's pretty close to 20. And from there we'll draw the solid line as well. So it's getting closer to this intersection here, but it would be down below the C-axis. And so this one is greater than or equal to. So it needs to be in this region here. So it looks like he'll be able to cover his expenses. Somewhere in this region is where he's going to end up being in order to cover the expenses and work in those 20 hours. So the next problem says that Brittany wants to bake at most 10 loaves of bread. Okay, and the bread for a bake sale, she wants to make banana bread and sells for $1.25 each, and nut bread. So we've got two different variables. We've got banana bread and nut bread. So how about we go with B stands for number of loaves. Loaves of banana bread. And we'll go with N equals the number of loaves of nut bread. So now we'll go ahead and set up our two equations. So at most 10 loaves is what she wants to do. So N plus B is going to end up being less than or equal to 10. So she doesn't want to make any more than 10. Now it says that she's going to sell the banana bread for $1.25, nut bread for $1.50. So nut bread 1.5 N plus 1.25 B, and it says she wants to make at least $24 in sales. So greater than or equal to 24. Let's see if she can do it. So let's go by, how about, I guess we can probably go by close to ones. Let's go by twos. So this will be 4, this will be 8, 12, and this is going to be 16 and 20. And we'll do the same thing over here, 2. This is, actually that's not 2, that's going to be 4. So let's fix that. This will be 8, 12, and 16 and 20. And we'll go ahead and solve. And so N plus B is less than or equal to 10. So let's go ahead and come up with some what the axes are, and so we'll call this the number of loaves of banana bread. So we'll go with number of loaves. Oops, get that A in there. Let's try that again. Loaves of banana bread, and this is number of loaves of nut bread. Alright, so we're on the N plus B is less than or equal to 10. So let's go ahead and plot the 10. Point on 10, a point on 10, and it's going to be a solid line again, because it's at most, and it's less than or equal to, because this person doesn't want to make any more than 10 loaves. And then we'll go ahead and solve for the other. So I'll set 1.5 greater than or equal to 24, and this is N there, and then we'll do the 1.25 is greater than or equal to 24. So let's go ahead and pull up the calculator here, and we'll do 24 divided by the 1.5 first, and that's going to give us 16. So N is greater than or equal to 16, and then we'll do the same thing. We'll do 24 divided by 1.25, and that gives us 19.2. So this was B here. So B is greater than or equal to 19.2. So now we're ready to go ahead and plot some of those points. So we'll go with, let's go ahead and plot the N on the N axis, 16 spaces up, and on the B axis, 19.2. And so we'll draw a line between those two. And this is what she wants to make. Now, since it says at least, that means greater than or equal to. So you see that line would be up this way. So that means we would shade up here, and down here we would shade below. However, we have a situation here where we have no solution. So there is no solution. That means that she's going to have to, we could say, Brittany will have to bake more than 10 loaves to make $24 or more. So that's our situation on that one. Let's take a look at some other problems. Here we have to write a system of equations. And so here, typically we could just go ahead and look for the y-intercept and the slope. However, this y-intercept's kind of tough, so I'm going to go with using the points that they give me. So negative 4, 2, and it looks like 3, negative 3. So I need to find the slope of that line. So m equals negative 3 minus 2. And then, since I start with the negative 3, I'm going to do 3 minus negative 4. So we do some work there. It makes negative 5 over 7. So that's my slope, and I'll take one of the points. How about negative 4, 2? So y minus 2 equals negative 5 sevenths times by x minus negative 4. So I'll add the opposites there. And I've got y minus 2 equals negative 5 sevenths x, and this is going to be negative 20 sevenths. And so I'll have to add the 2. Now when I'm adding 2, I want 7 as the denominator, so I'm going to change that to 14 sevenths, and that leaves me with a y. Now this should not be equals. We're going to fix that in just a minute. Negative 5 sevenths x minus 6 sevenths. Okay, so it's a tough problem there. So let's figure out the inequality sign. So this is where the solutions are, and so that means it has to be above this line and it's dashed. So I'm going to change this inequality sign right now, that equals sign, to a greater than, because it has to be above that line and dashed. And so let's take a look at the next one. So I'll use negative 4, 1 and 2, negative 1. We'll start with the slope, and that's going to be 1 minus negative 1. That's going to be over negative 4 minus 2. So I'll add the opposites there. I get 2 over negative 6, which reduces down to negative 1/3. So I take that slope, and I'll use the negative 4, 1 this time. So y minus 1 equals negative 1/3 times by x minus negative 4. So I'll add the opposite a little bit more there. Y minus 1 equals negative 1/3 x, and then minus 4/3. So I'll add the 1. Now, I'm going to treat 1 as a fraction of 3/3. So I need to add 3/3 to both sides, and I get y equals negative 1/3 x minus 1/3. And so those are my two equations. Now I just need to figure out the inequality sign for that, though. So let's go ahead and erase that equals sign and change it to what it should be. So it should be below the line, dashed. So that means a less than. So here's my system. Y is greater than negative 5 6 x minus 6 sevenths, and y is less than negative 1/3 x minus 1/3. That is the system of inequalities. Let's try to graph some. And so on that first problem here, it says 5x plus 7y is greater than negative 6. I'm going to use intercepts here. So I'm going to just set 5x greater than negative 6. So that means x is greater than negative 6/5. And so that means that is going to be over to the left, just past the 1. And then I'll do the same thing for the next one. So 7y greater than negative 6. So y is going to be greater than negative 6/7. So I just go down almost to the 1 there. And then you've got 2 points. You can draw the line. So it's going to be a dash line. So dash line. And it's going to end up being y is greater and x is greater. So it's going to end up being above and to the right. So I'll just draw arrows in the direction I should shade. And let's take a look at the next one. So the next line says, I'll use intercepts again, was x is less than negative 1. So that's easy. So I go over 1 space. So right there. And then y says 3y is less than negative 1. So y is less than negative 1/3. So less than negative 1/3 is going to be somewhere around there. And I draw the line. Another dashed line here. Going through those 2 points. And I can see the 4 regions. Y is less, x is less. So that means down below and to the left. So this is going to be the directions. So the area they agree is right kind of to the, well, below the blue line, above the black, kind of down and to the right. So let's take a look at the next problem here. And it says x plus 4y minus 2. Okay, so I'm going to move that minus 2 over. So it's going to be x plus 4y is greater than or equal to positive 2. So just move the sign or change the sign when you move the term to the other side. So I'll set up my two problems here and divide by 4, and I've got y is greater than or equal to 1/2. So x is greater than 2, so go over to 2 on the x-axis, and y is greater than or equal to 1/2. Draw the line, this time a solid line through these points, and it needs to end up being greater means above, so I'm going to end up shading above there. Now let's take a look at our other line. It's going to be 2x minus y is greater than, I'm going to subtract the 1 from the 2, is going to give me 1. So 2x greater than 1 and negative y is greater than 1. So it's going to be x is greater than 1/2 and y is less than. Switch the sign because you divided by negative. And let's go ahead and plot the points. So x is greater than 1/2. So we'll put the dot there. And negative 1 for y. And let's draw the line. This time a dashed line. And then I need to figure out its shading. So x is greater, y is less. So you can see how those have to agree. So greater means to the right, less means down. So you can see the region that we would shade would be right in here. So those are the types of problems you're going to see on tonight's homework. Good luck.